Hello everyone, welcome you all to this video. I am Pratima. Today we will learn how to check the differentiability of a function. We have learned to check the continuity of a function. We know that every function is not continuous and every function is also not differentiable at all the points. If you have not checked the continuity, you have not watched the video, please watch once, then you come for this differentiability of a function, how to check it. So let us start the lesson. So students, today's lesson is how to check the differentiability of a function fx at x is equal to a. Fx is differentiable at x is equal to a, we say if right hand derivative is equal to left hand derivative, or simply we denoted RSD and LSD. Now what does it mean? Derivative meaning we know, that is denoted by f dash x, which is ratio of change of fx to change in x, or ratio of change in y to change in x when the change is very small or very negligible. When we make a positive change or increase the value of x, we say the derivative as right hand derivative. We denote it f dash x is equal to limit h tends to 0 fx plus h minus fx upon h. But if we make a negative change or decrease value of x, we say the derivative as left hand derivative. So it is denoted by f dash x is equal to limit h tends to 0 fx minus h minus fx upon minus h. Change is negative here. So right hand derivative of fx at a is limit a plus h minus f of a by h, and left hand of fx at a is equal to fa minus h minus f of a by minus h. And if these two are equal, we say function is differentiable at x is equal to a. Now let us see its geometrical meaning. This is function fx. We have taken as point A, f of a. I made a little change in positive direction. So now x becomes a plus h. So that is the value of y. Then we'll get change in x and change in y. So change in x is h and change in y will be is equal to fa plus h minus f of a. And this angle we denote as theta 1. Change in negative direction. I am decreasing the value of a by h. So now x is a minus h. So y will be f of a minus h. Then what is change in x? It is h again. What is change in y? So change in y is f of a minus f of a minus h. And here the angle I denoted as theta 2. So now we'll make a relation between theta 1 and theta 2. If theta 1 is equal to theta 2, then tan of theta 1 will be equal to tan of theta 2. And what is tan theta 1? That will be slope of the tangent. Tan theta 2 is slope of the tangent in left hand direction. If these two will be equal, then it will be differentiable. So I am just magnifying this figure. So this is the figure magnified. So from this figure it is clear that tan theta 1 is equal to Rn by Pn and tan theta 2 is equal to Pm by Qm. Now tan theta 1 is equal to Rn by Pn is equal to f of a plus h minus f of a by h. Now when h is very small, I can put the limit. So tan theta is equal to limit h tends to 0 f a plus h minus f of a is equal to h. So this is your right hand derivative. So right hand derivative of fx is denoted by f dash a plus, which is limit h tends to 0 f a plus h minus f of a by h. So right hand derivative is cleared. Now we'll go for left hand derivative. For left hand derivative, we'll get tan theta 2. Now RHD we have already fixed. This is limit h tends to 0 fa plus h minus fa by h. Now tan theta 2 is equal to limit h tends to 0. This is Pm by Qm or f of a minus f of a minus h by h. Now to make it similar with RHD, I can write it is equal to limit h tends to 0 f a minus h minus f of a by minus h. So I took a minus common and wrote similar to RHD. So LHD of fx at x is equal to a is denoted by f dash a minus. So this is limit h tends to 0 f of a minus h by f of a divided by minus h. So now if tan theta 1 is equal to tan theta 2, then RHD is equal to LHD. Then only fx is differentiable at x is equal to a. So now let us summarize. If limit h tends to 0 f of a plus h minus f of a whole upon h is equal to limit h tends to 0 f of a minus h minus f of a is minus h, then fx is differentiable at x is equal to a. So we learnt the differentiability. Now let us see how the questions are framed on this concept and how we solve the question. Coming for first question. Question number 1. Find whether f of x is x square is differentiable at x is equal to 2. So this is a very simple question. You will recall the fact that this is RHD and second one is LHD. We will see that they both are equal to each other or not. RHD is equal to f dash 2 plus. So limit h tends to 0, f2 plus h minus f of 2 by h. 2 plus h means in place of x we'll put 2 plus h. So it will be 2 plus h whole square minus 2 square upon h. It will limit h tends to 0, 2 plus h whole square minus 2 square by h. So again you expand it, 4 plus h square plus 2h minus 4 by h. 4 cancelled, you are getting h common, h plus 2 by h cancelled, h we are putting 0, the value is 2. Coming to left hand derivative. Left hand derivative is f dash 2 minus. This will be limit h tends to 0, 2 minus h minus f of 2 by minus h. So here you have to keep in mind that h should be negative h. Now in place of x we'll put 2 minus h whole square. So limit h tends to 0, 2 minus h whole square minus 2 square upon negative h. So limit h tends to 0, 4 plus h square minus 2h minus 4 by negative h. So 4 cancel, again h taken common. So this will be h minus 2 by minus h. So why you are getting RHD is equal to LHD. So fx is x square is differentiable, but x is equal to 2. Next question. Find whether fx is x minus 5 modulus function is differentiable at x is equal to 5 or not. So recall the fact, we have to verify these two are equal or not. Now RHD is equal to f dash 5 plus. So limit h tends to 0, 5 plus h minus f of 5 by h. So in the modulus function we'll put 5 plus h minus 5. So this will limit h tends to 0, 5 plus h minus 5 minus 5 minus 5. So you are getting h by h, this is 1. If it's not clear, you can pause the video, you can understand yourself. Similarly, LHD is equal to f5 minus, it will be 5 minus h minus f of 5 by negative h. So you will put 5 minus h minus 5, again it will be minus 5h modulus, it will be plus h. The plus h by h is minus 1. So RHD is not equal to LHD. So fx is x minus 5 modulus is not differentiable at x is equal to 5. Now coming to next question. Find whether fx is equal to x square plus 5x greater than equal to 0, less than equal to 1, and 2x plus 4x is greater than equal to 1, less than equal to 3. You have to check the differentiability at x is equal to 1. So what is left hand derivative? F dash 1 minus, that means less than 1. Less than 1 means you will put x is less than 1. X is less than 1 means you will put it is x square plus 5. So in place of x square you will put 1 minus h whole square. Plus 5 minus 1 square plus 5. If we simplify this, you can simplify yourself also. So we'll take h common, h minus 2 by h. H is cancelled, minus 2 by minus 1 you are getting plus 2. And for right hand derivative you will take the value 2x plus 4 because x is greater than equal to 1. Right hand derivative is f dash 1 plus is equal to limit h tends to 0 f1 plus h minus f of 1 upon h. So here you will put at second function 2x plus 4. So once you will put 1 plus h, once you will put 1. So it will be twice 1 plus h plus 4 minus twice 1 minus 4. So here if we simplify, it will give you 2. So RHD is equal to LHD, fx is differentiable at x is equal to 1. You can practice more questions to develop your problem solving skills. All the best for your future. Thank you for watching and hope you to subscribe if you liked the video. Subscribe and the video.